Okay, seems like it's on. Hi, this is Hyun-Kyung Lee from Yonsei University. My department is called Culture and Design Management. I'm an associate professor at there, and at this time I'm presenting about the Polyhedra, which is the title of this preceding paper is Integrative Ways that the Knowledge of Polyhedra have developed in history, implications for art education and exhibition design. Okay, what I like to tell you about is the polyhedron. As you guys know, the polyhedron is used in everyday life in our many areas. It can be started with chemistry, biology, math, architecture, physics, art, and philosophy, and history. So it's a structure used in various fields, including mathematics, architecture, chemistry, and the art. So this article is based on the hypothesis that the knowledge of Polyhedra has developed in diverse, mutually influenced fields and has facilitated many crucial innovations in history. So the theory of Polyhedra has exercised a far-reaching influence on science, mathematics, and art and architecture, crossing over those different disciplines. So the research question is how knowledge of Polyhedron in different fields have mutual influences by representing the intriguing ways in which diverse figures in various fields influenced each other regarding the subject of Polyhedra. We can contribute to an understanding of the complex ways in which our knowledge has developed throughout history. We use a qualitative method to collect and analyze data from the literature on Polyhedra from ancient philosophy to contemporary art and design. The ultimate goal of this study is to provide an interesting and useful resources for educators and curators to help students understand the integrative ways that human knowledge has been formed and developed creative thinking. So the keyword is polyhedron, polyhedra, nanochemistry structure, platonic solid, Buckminster's Fuller's structure, a Leonardo da Vinci sketch, and Euler theorem. Okay, so here it goes with the introduction. Polyhedra has diverse origins and development paths and have been used in such fields as mathematics, astrophysics, architecture, chemistry, and art. So despite the different development applications, the polyhedra used in different fields shares similar concepts. Our research question is how have the concepts of polyhedra developed in various fields influenced one another? With this question, we'll test the hypothesis that the knowledge of polyhedra in various fields developed by making influence on one another throughout history. After showing the stories of the mutual influence of different concepts of polyhedra, we'll discuss that they can be used in convergence education and art exhibition, showing how diverse fields are intertwined. Our literature review starts with the definition and origin. To arrive at the rigorous definition of the polyhedron is a difficult task. However, broadly defined, polyhedron is a three-dimensional geometric object constructed from flat polygonal faces, straight edges, and sharp corners and verticals. The term polyhedron originates from the classical Greek poly, meaning many, and hedra, meaning seed or base. The common cube and pyramid and soccer ball shaped truncated isohedron are example of polyhedral. The origins of the polyhedron concept date back to the Neolithic area. Hundreds of carved stone polyhedral balls dating from around 2000 BC have been found in Scotland. The Egyptians were also interested in polyhedra, as evidenced by their pyramids, and the Babylonians applied a similar concept to calculate the volumes of solid objects. The Etruscan ancient Italy was also aware of some regular polyhedra. Okay, so in this picture, these all 5 polyhedron was used in everyday lives, and it was influenced to this scholar and the other scholar by crossover the disciplines. That's the point of what I'm telling you. So the ancient era, the integration of mathematics, science, and art first. Despite the older origins of the concept, the earliest records available today are the works left by the classical Greeks. More importantly, their approach is distinct from the preceding one insofar as they try to prove their findings. Approaching the knowledge of polyhedra mathematically, Pentagonian or Pythagorean and Theoretus discovered their regularity. Pythagoreans are considered to have discovered the cube, the pyramid, and the dodecahedron. Plato from 428 to 347 BC described the 5 polyhedra in detail of chimeros, in which associated each of the 4 classical elements comprising the world: earth, air, water, and fire, with the regular solid. Although he was not the first to have discovered the 5 regular polyhedra, he incorporated knowledge of the 5 regular polyhedra into his philosophical system to explain the world. However, Plato neither proved the theory nor formally indicated it required properties for the regular polyhedron. So it was Euclid of Alexandria, the father of geometry, who proved that the 5 Platonic solids are the only regular polyhedra and described their construction in his mathematical and geometric treatise Elements. Archimedes of Syracuse, a Greek mathematician and engineer, further expanded Euclid's study by discovering semi-regular solid called the Archimedean solid or Archimedean semi-regular polyhedra. Okay, so that was the kind of the literature review that I was starting with. Next. So these are the form like Kepler or all the other scholars from astronomer, astrologer, who was a key figure in the 7th century scientific revolution. They found some polyhedron concept was crossly influenced together from here to there, as you see this data collection. So as you see from here, all the area like chemistry or architecture, mathematician, they are all influenced together from Platonic solid, Pythagorean theory, or some architecture, all overlapped. So I organized this table by collecting data into the chart showing below. The data looks as a polyhedral relationship between scholars and how these solids cut across fields of study and affect each other. For example, the tetrahedron above there, top of the first, is described with basic two-dimensional figures. The reference images are what the polyhedron affects. So to Platonic solid, Kepler's Platonic solid model of the star's solar system from Mysterium Consconium. Yeah, okay. So let's go to the next section. And here's some findings that I found and directed by the arrow, how all the scholars and areas are influenced together and each other. So the influence of the polyhedra theory crosses science and art throughout history. My findings as a floor plan for the Polyhedra exhibition in a science museum. Okay, so polyhedra have been and continue to be highly useful tools from the representation of chemical structures, but are also idealization in the human mind of perfection and structure, as in the early association of the four elements of the Platonic solid. That's what I found from the Wikipedia 2018. So people see the world with their level of information and knowledge. So rather than scattering information about organizing relationships and intertwining stories, the exhibition on Polyhedra's relationship in science and art would be interested in the geometrical aspects of polyhedra. Like here, so regular and non-regular and chemical structure. So in this paper, I wanted to analyze this complex relationship to help middle and high schoolers from a different perspective of science and art. The art of sculpture at the atomic scale. Moreover, even thoughts that are wrong can be important. For example, Kepler's astrophysics thoughts were abandoned at the time, but were later used to help other scholars' theory. The next step in this research is to plan an exhibition with the contents of this polyhedra analysis. Since the task needs a lot of expertise from exhibition planning and designing, hopefully this article will convince curators to analyze how science and art related in polyhedra. Yeah, so as you can see from here, here's a lot of science fields exhibition that's trying recently with some sensors and sensitivity and art and science all together with the technology showing how the human life and history were developed and intertwined each other. That could be more organized in detail, and we can show them visually at the exhibition. That can be the goal, how all this discipline and convergence of educational area can be put together at the exhibition area, so the educator or the students from elementary, middle, and high schooler come together and learn about all the intertwined influence. Then that would be one of the practical and live education that we can provide as a high education scholars. Yes. So as demonstrated in the data analysis section, the displayed at the above diagram, knowledge and theory of polyhedra have been developed by crossing over different fields and transcending the boundaries of space and time. Contrary to the popular belief that there is little relation between the arts and science, this paper shows the close association between the two fields. More importantly, we have found that many great discoveries were amalgamative. Most of the key figures who have developed innovative appreciation of polyhedra were not confined to a narrow discipline. In the ancient, Renaissance, and early modern eras, in particular, polyhedra was studied by interdisciplinary scholars whose interest lays in diverse fields. Even in the 20th and 21st centuries, when individual disciplines were firmly established, great innovations came from convergence of knowledge. As demonstrated by Euler and Fuller, these versatile innovators in turn have a multifaceted impact on diverse fields. So by showing the mutual influence of diverse from the knowledge, instead of simply surveying their development, this article provides a broad picture and the mechanism of how human knowledge has been accumulated and spread. Although we are familiar with knowledge of particular disciplines, much of our knowledge has evolved across diverse fields. In this long process, knowledge was often limited and proven wrong later. However, since knowledge carries importance for its impact on further knowledge, for example, Plato's idea of four regular polyhedra can be seen as philosophy rather than science, as he did not prove it. However, his idea influenced the various mathematics, scientists, and artists. Kepler, who was one influenced by Plato's four-element theory, used an idea when he explained the orbits in which planets move around the sun. So while Kepler's distance estimate proved it to be wrong, this Platonic model suggested a possible mathematical synergy between microcosm and microcosm and contributed to the development of modern science. Okay, so conclusion is here. Since the ancient era, polyhedra have attracted many thinkers who try to understand and explain the world in different ways. Some developed mathematical theories of polyhedra, while others made an effort to understand the cosmos using them. Many artists have also used the polyhedra in their works. Scientists have been inspired by polyhedra, and architects have created efficient structure using them. Recently, the knowledge has been actively utilized in diverse fields, including nanoscience and computer science. So this history of knowledge of polyhedra can be an effective tool for meeting theories and teaching theory concept in the fields of mathematics, science, and arts. Especially, our findings could be used to help students more easily access to mathematical theorems and scientific theories. For example, a math activity entitled Geodesic Dome Challenge was designed and run as a countrywide inter-school challenge during the 2019-20 academic year, with the goal of providing context and fun to math curriculum from K-12, KS2, 3, and 4 students. The intriguing stories of Polyhedra could inspire curators to design exhibitions showing how knowledge has been formed, representing the intriguing ways in which diverse figures in various fields influence each other in the development of Polyhedra can help understand how knowledge of science, art, mathematics, philosophy, and architecture has been a crossover throughout history. The data collected in this paper would also provide useful content of such an exhibition. Furthermore, this article will contribute to museum education by providing useful ideas and content for creating an exhibition about the integration of art and science. By demonstrating the specific ways in which scholars and artists derive the inspiration and ideas from Polyhedra, the exhibition could enhance its educational role. It is hoped that this article will offer ideas and insights to curators and educators. So as you can see from my conclusion, this article's analysis and data collection can be curated as an exhibition from art museum, science museum, or design museum, so that all the elementary, middle school, high school students can come and learn how the human life or history or all the others are intertwined, and learn from each other, and then created some other theory, new theory, and then that new theory was influenced to other famous scholars, and this scholar could develop some more brilliant and important knowledge. So it was all developed and intertwined and influenced, circulated together, and we are here learning from them, and we are now exactly creating something for the future generation. So this kind of article can be, can make students think of their behavior or how they exist are very, very valuable and important as well. And then all the historical artifacts or the facts can be used to utilize their knowledge and information, and that can be transcend to the future area. So you're the one who's not important, who is really, really important person who can deliver your important knowledge to the future generation. Does it make sense? Yeah. That's the core point of this article. Okay. Seems like my presentation is done. So hope you have a great inspiration. So if you have any question, then feel free to ask me by email. Okay, thank you very much. I'll see you later. Thank you.